everyone, it's Miss Joyce. I'm sorry I can't be here this week with you, but I hope you all are staying safe and working hard, and I hope to see you on Monday. Today we're going to be working on understanding fractions. Let's start with fill in the blank. So blank represents equal portions of a whole. Examples include 1/2, 3/4, 2/5, 3/3, and 5/4. All of these are examples of a fraction. So fractions represent equal parts of a whole. The number on top is known as the blank. This tells us the number of parts shaded. So the number on top is known as the numerator. This tells us the parts that we're going to shade out of the whole. So we're going to circle the numerator in each of the fractions. So in 1/2, the number on top is 1, so that means we'll shade 1 out of the 2 parts. With 3/4, the numerator is 3, meaning we're going to shade 3 out of the 4 parts. For 2/5, the numerator is 2, meaning we're going to shade 2 out of the 5 parts. For 3/3, the numerator is 3. That means we're going to be shading 3 out of all 3 parts, or we're going to be shading the whole thing. And with the last one in 5/4, the numerator is 5, meaning we'll be shading 5 out of 4 parts. We're going to talk in a little bit how that makes sense and how we could shade 5 parts if there's only 4 parts per whole. The number on the bottom is known as the blank. This tells us the number of parts needed to make up one whole. So the bottom number is known as the denominator. This tells us the total number of parts that make up one whole. So we're going to put a box around the denominator in each fraction. In 1/2, the denominator is 2, meaning there are 2 parts making up one whole. In 3/4, the denominator is 4, meaning there are 4 parts in one whole. In 2/5, the denominator is 5, meaning there are 5 parts making up one whole. In 3/3, the denominator is 3, meaning there are 3 parts that make up one whole. And in the last one, 5/4, the denominator is 4, meaning there are 4 parts that make up one whole. Let's write the fraction on the line that each visual model represents. So let's start with this first one. We can see that there is 1 part shaded out of 2 parts. So we can write this as 1/2 or 1/2. In this next one, we have 2 parts shaded, so the numerator will be 2 out of 3 parts. So this represents 2/3. The number 2 represents the amount of parts shaded, and 3, the denominator, tells us the number of parts in the entire whole. For the next one, we have 3 parts shaded out of 3, 4, 5, 6 parts. So this represents 3/6. In this next model, we have 3 parts shaded. Even though they're not all together, there are still 3 parts shaded out of 3, 4 parts. This represents 3/4. In this next one, we have 3, 4, 5 parts shaded out of 5 parts. So we have 5/5 shaded, which also means we have the entire model shaded. So this equals one whole. In this last one, we can see that we have 1 whole shaded and 1 portion out of 2 of the next whole shaded. So this shows that we have 1 and 1/2 shaded. And so the 1, the big one in front, means we have 1 whole model shaded. The 1 on top means we have another part shaded. And the 2 on the bottom says that there are 2 parts that make up one whole. Even though there are 4 parts altogether, the denominator tells us how many parts make up one whole. So if we look, there's 2 parts that make up each whole. That's why the denominator is 2. Another way we could write this is by just counting the total number of parts shaded, which is 3 parts shaded out of 2 parts in each whole. So this could be written as 3/2 or 3/2. The numerator 3 shows there's 3 parts shaded, And the denominator, too, tells us there's 1, 2 parts in each whole. Let's continue with some fill in the blanks. When all the parts are shaded, it is known as a whole. So that means the entire bar or model is shaded. An example of a whole would be this model here. We can see that there are 1, 2, 3 parts shaded out of the 3 parts. So we could write this as 3/3 or 1 whole. When more than a whole is shaded, this can be known as a mixed number or a fraction greater than 1. So for example, here we have 1 whole shaded, 1 whole model is shaded, and 1, 2 more parts out of 1, 2, 3. So we could write this as 1 2/3. The whole number in front shows that there's 1 whole shaded. The 2 in our numerator represents the 2 more parts shaded in the next model. Out of the 3 is the denominator because there's 1, 2, 3 parts. We could also rewrite this as a fraction greater than 1. This means that the numerator on top is going to be bigger than the denominator on the bottom. So we could count all the shaded parts. 1, 2, 3, 4, 5 parts shaded out of 1, 2, 3 parts in each whole. So that's how we're getting 5/3. 5 parts shaded and 3 parts make up 1 whole. Here, a fraction that represents the same amount shaded as another fraction is known as equivalent fractions. So we're going to look at an example. We're going to be looking at 1/2 and 2/4. And we know that these are equivalent because the same portion of the whole is shaded. So let's look here. This is our first model, and this is our second model. On top, we can see half of the whole is shaded. On the bottom, even though there are more parts, the same amount of the entire whole is shaded. We can see that here because if we line them up, we can see the amount on top that's shaded matches the amount on the bottom that's shaded. So notice that the whole is the same size. The parts on the bottom are smaller, but more of them are shaded, meaning the amount of the entire whole shaded is the same for both models. That's how we know that these are equivalent. So let's go ahead and try finding some of these equivalent fractions. We're going to circle the models if they're equivalent. And if they're not equivalent, we're going to put an X on them. So let's look at this first set. Here on top, we have 1/3 of the entire model shaded. On the bottom, we have 2 out of 6 parts shaded. But if you look at the shaded parts and line them up, we can see the same portion of the whole is shaded. So these two models are equivalent. They have the same portion of the whole shaded. Let's look at this next one. Here we have 2/3 shaded because there are 2 parts shaded out of 3. On the bottom, we have 2/6 shaded. Even though we have the same number of parts shaded, the parts on the bottom are much smaller. So they actually don't shade the same amount as the parts that are shaded on the top. We can see the model on the top has a lot more shaded than the model on the bottom. So these fractions are not equivalent. We're going to put an X on them. In this last one, we have 1/4 shaded on top. And on the bottom, we have 2/8 shaded. So we can see that there are more parts on the bottom, but they're much smaller. We just want to see if the same portion of the whole is shaded. Well, if we line them up, we can see that the amount shaded is about the same for each of the wholes. So these two fractions are equivalent.